Hi, in this video we are going to implement HashMap with linear probing. So I'm going to create a Java project, HashMap linear probing. Let's create a class, for example, the application.java with the package name com.myname.linear, for example, whatever. We are going to have the constants again because we are going to store the table size in this constants class. So we have a private constants constructor. Okay, and the public static final integer table size, which is going to be equal to 10. We are able to store up to 10 items in our hash map. And I'm going to create a class for the hash item. In this case, we are not going to use linked list, so hash item is not going to store a reference to the next hash item. We just have to store key value pairs. So we have the key as an integer and value as an integer. We just have to generate a constructor. So source generate constructor using fields. I'm going to get rid of this. And we just have to generate getters and setters. So source generate getters and setters for the key and the values. Ctrl-Shift-F to auto format. And basically that's all about the hash item. Again, in the previous implementation when we were considering chaining, we had to use a reference to the next hash item because we solved collision with the help of linked list. Here we are not going to chain these hash items together, so that's why it's not needed. Okay, let's save it. I'm going to have a class, for example, hash table. And of course, we have to create a one-dimensional array as an underlying data structure. So we have a one-dimensional array of hash items, and basically this is the hash table. Okay, and we just have to instantiate this hash table. So this hash table is equal to a new one-dimensional array of hash items. Sorry for that, not the key value pairs. And the size is going to be equal to the constants.table size. Okay, this is how we instantiate an array with as many items as the table size. We are going to have the public void put method with the key and the value pairs. Okay, we have to generate an index. So generated index is equal to a hash function with the key. Of course, we have to implement this hash function. It's going to work just the same, so we are going to return with the key and the modulo operator with the constants.table size. Okay, and basically we just have to check. It's quite easy to implement linear probing. We have to check whether the hash table where the index is equal to the generated index is not equal to null. If it's not equal to null, it means that we have already inserted some item there, so it is a collision. We have to consider the next item. And basically we just have to generate another index. It's going to be the generated index plus 1, and we have to use this modulo operator to make sure that we are not going to get an array index out of bound exception. So basically this is how we transform a given integer, so an index, into the range 0 and the table size. Okay, and basically after this while loop, we know for certain that there's no item in the hash table where the index is equal to the generated index, so we just have to insert this hash table generated index is equal to a new hash item. So we know for certain that we are able to insert a new hash item in the generated index because this is how we make sure that the generated index is not going to store anything in the hash table. So that's all about the put method. We just have to generate indices with the help of hash function. This is what we have been discussing, that for example we would like to insert 100 with the key strawberry. Okay, this 23 has already been inserted here, so we have to generate another index. Let's consider the next array index. Okay, it is still not a null, which means that it is not an empty array bucket. We have to consider the next one. So basically this is what's happening here. Okay, is it not equal to a null? It means that it is a collision. There's already a hash item inserted with that given index. So we generate the next index, and in linear probing, we just increment it by 1. So this is why it is the linear probing, because we consider the next array slot. Okay, thanks for watching.